today's environment, it has become increasingly more important to protect our staff while still being able to communicate with your clients, particularly as banks, building societies, NRMA, etc. are trying to have a friendlier environment. This, however, does come at a cost. By opening up these offices, it makes it much easier to physically abuse your staff. In the light of this, Mulford Plastics would like to demonstrate the 3 typical materials being used today for anti-jump screens. These materials are acrylic, laminated safety glass and Lexan Margard polycarbonate, MR10. We're about to show the abrasion resistance of acrylic compared to Lexan MR10. Lexan MR10 has a proprietary silicon hard coat that is applied to both surfaces of the Lexan panel after manufacture to provide greater serviceability and prolong the life of the glazing. As you can see, acrylic will scratch much more easily than Lexan MR10, which will result in visual impairment and the need to replace the screen much sooner. The left panel is 10mm acrylic, which is currently one of the most common materials used for anti-jump screens to provide a barrier between staff and the public area. The initial blow is conducted using a 3.6 kilogram sledgehammer. As you can see, one blow and large, sharp shards of acrylic are projected into the staff area, potentially causing severe injuries to staff members and allowing easy access through to the security areas. The panel on the right-hand side is laminated anti-bandit glass, 11.52 mm thick. Again, the initial blow was conducted using the same 3.6 kilogram sledgehammer. With the first blow, the head of the sledgehammer penetrated the safety glass and caused a heavy amount of spalling to flow into the security area, potentially causing eye injuries to your staff. After several more blows with the sledgehammer, it further weakened the safety glass's integrity and caused further spalling. Although in this case access was not breached, this is because the demonstration panel is only of a small size, approximately 915 by 610 millimeters. If this panel was full size and fixed in accordance with standard fixing methods, the panel would collapse, allowing again easy access to the security areas. The final material we're testing is Lexan MR10 6mm thick, which has an abrasion-resistant proprietary hard coating as demonstrated earlier. The first attack was conducted using the same 3.6 kilogram sledgehammer. After several blows, the Lexan MR10 was not breached and there was no spalling from the rear to injure staff members. In fact, the only apparent damage was surface scarring. We then attacked the Lexan MR10 panel with an axe. Again, after several blows, the Lexan MR10 did not crack or cause spalling. The only damage was more scarring of the sheet. The final test was performed using a log splitter. As you can see, the security and staff safety was maintained throughout the entire sustained attack. The panel we're demonstrating is on the right-hand side of the frame and is laminated anti-bandit glass, 10.38mm thick, with anti-spall film applied to the rear of the panel. Again, we used a 3.6 kilogram sledgehammer. After one blow, again security was breached. The anti-spall film did aid in reducing the amount of spalling that was projected to the rear of the panel. But as you can see, there was a considerable amount of shattered glass that was projected into the safety area. We then conducted the same test using Lexan MR10, the only difference being that we had voice transmission cutouts in the panel. We used the same 3.6 kilogram sledgehammer for the initial test. Again, after several blows of the sledgehammer, only surface scarring was present, with no breaching of the security panel whatsoever. We then attacked this panel with an axe. After several blows with the axe, a crack began to form from the edge of the cutout, which was actually cutting the sheet of MR10. No spalling was evident. Further axe blows extended the crack, however, the crack did not travel far enough after a prolonged attack to breach security. As you can clearly see from these graphic demonstrations,